Hello and welcome back to the Java series. In this video, we will go over collections available in the Java API. Most collections are available in the Java API, and while we won't go over all types of collections available, there are many, we will go over some of the more common ones as well as storage options that these collections can use. The first structure I wish to discuss are regular arrays, which is a feature of Java itself. The array is known by the use of the square brackets within their declaration, as well as element access. Basically, arrays store a series of elements contiguous in memory. Bear in mind three things. 1. While arrays can hold primitive types, they can also store objects as well. If they store objects, then what's stored in the contiguous strip of memory are references, not the objects themselves. 2. Arrays can hold only a fixed number of elements. If you need more elements, you'll have to create a larger array than the one you're currently using. And if you try to access an element at an index higher than what the array has, you'll get an index out of bounds exception thrown. 3. The index range starts at 0, so an array with 5 elements will have indexes 0 through 4. Before attempting to access an element, you should make sure that the index is under the array length attribute and not negative. The most common collection type in the API is the list. Most of these collections use generics to specify types, so you can only store objects in them. The list is an interface featuring methods you can call to manipulate the list. Two of the most common classes implementing the list interface is the array list and the linked list. The array list uses an internal array to store its elements. However, it can grow as needed because when the array gets full, the class will create a larger array, transfer all of its elements to the new array, and discard the old one. The linked list uses nodes to store its elements. There is a head node that represents element 0, a tail node that represents the last element, and each node has a reference to the next node in the list as well as a link to the previous node, a doubly linked list. While there are other lists available, those two are the two most well-known list types. But if you find yourself having to choose between the two, think about what you envision being done with the list. If you're going to be modifying the list, adding and removing elements a lot, use a linked list. If you are going to be doing more element access, use an array list. A set is similar to a list, but it has certain restrictions, such as each element must be unique and can contain at most one null element. In fact, a tree set won't even allow for a single null value. A tree set will attempt to sort its elements according to either the class's natural ordering or by a comparator. Another set type is the hash set, which internally uses a hash map, allows for null values, and makes no guarantee on the ordering of the elements. Before moving on to maps, I want to briefly discuss the idea of stacks and queues. Stacks operate on the idea of last in, first out, or first in, last out. In other words, the last element added to the structure should be the first one removed. The Java API actually provides a class called stack that uses a vector, which is similar to an array list, to hold its elements. A queue is the opposite of a stack, meaning the last element in should be the last element out, not the first. The queue is an interface that the linked list discussed earlier, funny enough, implements. All of the previously discussed structures implement the iterable interface. This means that they can be used in a for-each loop. The map is its own construct separate from the iterable and collections interface, but is often considered part of the Java Collections API. The idea behind a map is that you have a key-value pairs, and that by submitting a key into a map, you can get the corresponding value object. A basic implementation of the map interface would be the hash map, which is a basic implementation of map. A more complex map would be a tree map, which organizes like a tree and attempts to sort the pairs by key ordering so that key value access can be sped up. Thank you for watching. In the next video, we will explore basic threading.